Hello and assalamu alaikum. In this video, we will be implementing encoder, decoder, demux, and mux in Quartus. So, in previous video, we have implemented this encoder and decoder, mux and demux in in Proteus software, and now we will be implementing them in Quartus. So over here, I have made the code for encoder. So over here, you can see we are starting our code with the module, and this is the A is the name of the function, the file we have made. So module A is A. We are taking the inputs, four inputs of A, B, C, and D over here, and these out1 and out2 are outputs. So in order to make encoder, we are encoding 4 to 1, so 4 to 2. So we have two outputs, and in the first output we are making by making two making OR gate with this D and C input. This gives us the output 1, and output 2 is giving the D to the is the input to the OR gate, and this B is the second input to this OR gate. So by making the RTL view, this is the RTL view. This is the circuit diagram, as you can see. So this is the encoder, and there are two OR gates, and this output 1 and output 2 are being given out. So if I show you this waveform, I have given 0 1 0 0. So my waveform should give me 0 1 as in case encoder case. So here it is giving me 0 1 as the output. So we will moving on towards the our second, that is a decoder. So here in this decoder case, we have the two inputs A and B and four outputs. So inputs are A and B, and we have four outputs. Okay, so we are assigning making a formula of each four for each four. So the output 3 case is A and B, and with the B and get the A and B inputs, and the output 2 is coming with A to the AND gate, and the second input is the NOT of B, and the output 1 is NOT of A going to the input of AND gate, and B is the second input, and in the output 0, that is the first output, or A is the first input, the AND gate, and NOT of B the second input, this AND gate. So these are four formulas for the four outputs. So just waiting for our compilation to be done. So here you can see it's the RTL view of our decoder which I've made over here. Okay, so here we have four AND gates, and the A, B are the two inputs, and which are going in different conditions of not in these AND gates, and our output is coming. So if I see the waveform, I'm giving it 0 and 1. It is the input which we have got as the output from the encoder which we have done previously. So 0 1, so the output should come toward as we have given that as input in the previous case, that was 0 1 0 0. So here I have simulated it. So it's 0 1 0 0. So as you can see, it's working nicely and perfectly. uh, so this is our decoder case. So next we'll move on towards the demux. So here in Demux case, we have in and as and four outputs, out 0 to out 3, and we are input taking as in, and output are, as I've told, the four outputs. So in this case, we have made the code by using um, begin and always, using always statement, and making a case and type of case, and if s is equal to 0, we got the out 0 is equal to 1. So the out 0 should be put in that is the input we are giving. So similarly, if s is 1, output 1 should be in, and if s is equal to 2, the output 2 should be in, and output if s is equal to 3, the output 3 should be in. So in waveform we can see it is showing similarly that like Demux works similar to the as decoder. So as a given 0 and the 1, the output we are getting over here is 0 1 0 0. So the next case we are having over here is mux. So it's a multiplexer. Let's just add over here. So here is our case of marks, which we have module A, and we have four A, B, C, D as input. S is for selection, out is the output. So selection is a 2-bit selection. So input, as I've discussed, A, B, C, D. Output is the out single bit. So here we use always, and here we begin the loop. If s is equal conditions, if s is equal to 0, out should be 1. So, and if s is equal to 1, out should be b, and if s is equal to 2, out should be c. If s is equal to 3, our out should be d. So here I have made the uh, RDL view, the circuit diagram. It's quite complicated, it has made, but it works fine if we go to the waveform. So here I have given the condition that is 0 1 0 0, and or as it is the selection is 0 1, we are getting 1 on the output. So it's working nicely. So that was it from this video, in which we have discussed mux, demux, and encoder and decoder in Quartus. So thank you very much.